Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit and today's lecture is based upon the amplifier, which is also very important component in the electronic circuit. So in today's lecture we discuss what is the amplifier and how it is classified, how many types of amplifier we have. We will discuss one by one. First we start what is the amplifier. Basically the name suggests amplifier which amplify the signal. Which signal it amplifies? It amplifies the amplitude of the signal waveform. So an amplifier is used to increase the amplitude of a signal waveform without changing the other parameters. Only the amplitude will change here in the amplification. So the other parameters will remain same, such as the frequency or the wave shape will be the same. They are the most of the commonly used circuits in the electronic and it performs variety of functions in the great many electronic systems. And this amplifier is used in many electronic systems to amplify the signal. So what is an amplifier? An amplifier is an electronic device that increases the voltage, current or power of a signal. Amplifiers are used in the wireless communication system in broadcasting, in audio equipments of all kinds. They are basically categorized into the weak signal amplifier or the power amplifier. Weak signal amplifier means which increase the signal amplitude or signal wavelength from weak to the higher signal. And in the electronics, small signal amplifiers are commonly used devices that have the ability to amplify the small input signal into the larger one, into the high signal. For examples, if we take a sensor such as the photo device into a much larger output signal to drive a relay, lamp and loudspeaker, for example. Loudspeaker we use in the daily life, and that is the most common example of the amplification, which amplify the sound signal from the small input signal to the higher input signal. It converts the lower sound into the higher sound. Now there are the many forms of the electronic circuits classed as the amplifier, from the operational amplifier and the small signal amplifier up to the large signal amplifier, and there is the most commonly used the power amplifier. So amplifier can be classified on the basis of its amplification from the small signal to the larger signal to the power signal. Now the classification of the amplifier depends upon the size of the signal, large or the small, and its physical configuration, how it's process the input signal and how much signal we are getting as an output. So the amplifier designed in such a manner just to get the output signal of the very small input signal. So that is the relationship between the input signal and the current flowing into the loud, which convert the small signal into the larger signal. Now the classification of the amplifier. The amplifier classified accordingly. It's a type of signal, type of the configuration, its classification, class A, class B, and the frequency of the operation. Now type of the signal is a small signal, and type of configuration we take it as a common emitter, and the classification it will be the class A amplifier. Now the direct current is the frequency of the operational amplifier. Then the audio frequency is in the case of the larger signal. Larger signal, if we want the type of signal we get output as a larger signal, then we use the common base, then the class B amplifier. Then the audio frequency we will generally take for the frequency of the operation in the larger signal. Next is the common collector, which is the class AB amplifier and the class C amplifier. And class C amplifier, it contains the WHF, UHF and SHF and frequency. These are basically contains the other frequency also. So amplifier can be thought of as a simple box, or it is a block containing the amplifying device. What type of amplifying device it has? Which electronic component used in the amplifier? Generally we use the bipolar transistors. We use the field effect transistor, that is the FET, that is the BJT, or the operational amplifier. Operational amplifier most commonly used in the amplifier, which has the two input terminals and the two output terminals, and one is the common ground being the common, with the output signal being much greater than that of the input signal as it has been amplified. So here we came to know that the amplifier can be thought of as a simple box, and it's made of the devices like bipolar transistor, field amplifier, which has the input terminal, and as well as the operational amplifier. So an ideal signal amplifier will have the three main properties. What property? First, it has the input, second is the output, and third is the amplification. The input resistance, that is in the form of the resistance, output, that is in the form of the output resistance, amplification, which is basically as a gain, or we can represent it as a. No matter how complicated as an amplifier circuit, a general amplifier model can still be used to show the relationship of these three properties. Even if we are taking the larger output, then we have these three properties. First is input, output, and the amplification. Amplification, or the gain, that represent the amplifier. So on the screen we are having the ideal amplifier. How it is constructed? You see the left hand side there is a signal input Rin, and this is an amplifier, and the gain is represented on the right hand side circuit. Then that is a signal output. So amplified difference between the input and output signal, which is known as the gain of the amplifier. Gain is basically a measure of how much an amplifier amplifies the input signal. So then the gain will let you know that how much signal is amplified through this amplifier. If we take an example, then if we are having input signal of the 1 volt and the output we need a 50 volts, then a gain of amplifier would be the 50, as it converts from a lower signal of 1 volt to the 50 volts. So in other words, we can say that the input signal has been increased by the factor of the 50. This increase called the gain. That this gain is increased by the 50 times, as this is the amplified gain. And amplifier gain is simply the ratio of the output divided by the input. Ratio of the output divided by input. Here the input is the 1 and output is the 50. So 50 by 1 is the 50. So the amplified gain is simply the ratio of the output divided by the input. So we have in the example we have the 50 gain. So, and moreover the gain has no unit and it is in the ratio, but the electronics it is commonly represented by the symbol A. The amplification gain is amplified simply by calculated by the output signal divided by the input signal. What is an ideal amplifier? That is most commonly defined as the ideal amplifier. The characteristics of an ideal amplifier from our discussion about it regard as the gain, meaning it's a voltage gain. Here we define the resistance, so the output will be in the form of the voltage. If it is in the voltage gain, then it is the ideal amplifier. The amplifier gain defined by the capital A and will remain constant for varying value of the input signal. The output will be the same. If we take the input, if we vary the input signal, then still the amplifier gain will be the constant. Now gain is not be affected by the frequency, means frequency will not affect the amplifying, like the signal of all the frequency must be amplified by exactly as the same amount. The input may be any, the frequency will not change. The amplifier gain must add noise to the output signal. It should remove any noise in already exist in the input signal. Means this amplifier can not add any noise of the output signal. The amplifier gain should not affect the change in the temperature giving good temperature stability. Moreover, the gain of the amplifier must remain stable over the long period of the time. So these are some of the characteristics of the gain. In the case of the ideal amplifier, what properties it has? It has have a infinitely wide bandwidth, have a infinitely high gain available in the ideal amplifier that can be easily controlled, and in the ideal amplifier there is no distortion. It is ideally linear we have, and generate no noise and have a infinitely high signal to noise ratio. So no noise considered in the ideal amplifier. It will be easy, it is convertible to perform the different amplifier function, and this type of amplifier are a very cheap amplifier. What are the type of amplifier? The next topic is the type of amplifier. How we define the various type of the amplifier. Although amplifier are sometimes classified according to the input and the output parameters, but here we define that we can get that, and that the basic four type of amplifiers are: first is a current amplifier. As the name suggests, an amplifier that makes the given input current higher. In case, as the name suggests, there's a current amplifier, current will be amplified. So higher the current will be get as compared to the input signal. As the name suggests, an amplifier that makes the given input current higher. Output current will be the higher in respect to the input current. It has characterized by the low input impedance and high output impedance. In this type of amplifier, we give the low input impedance, and the output impedance will be high. Next type of amplifier is the voltage amplifier. Again, the name suggests the voltage output will be large. An amplifier that amplifies the given voltage for a large voltage output. It is characterized as a high input impedance and the low output impedance. You see the difference between the current. Here we are having the low input impedance and the output will be the high impedance. But here in the voltage, high input impedance and the low output impedance. In case of the voltage amplifier. And another type of amplifier is the transconductance amplifier, which an amplifier that changes the output current according to the changing input voltage. The current will change according to the voltage input. Next is the transresistance amplifier. That amplifier which changes the output voltage according to the changing input current. In the conductance, output current we take after changing the input voltage, and in the transresistance amplifier, output voltage accordingly the input current, and it's also known as a current to voltage converter. This type of amplifier is known as a current to voltage converter, and that the above one is the transconductor is the current to voltage to current converter. Apart from the basic types, there are the several other types of the amplifiers which are categorized on the basis of its application, operation and the characteristics. So we discuss one by one the various type of the amplifier. First is the power amplifier. Power amplifier, although not technically is a type, power amplifier is general terms that refers to the amount of power provided by the power supplying the circuit or amount of the power delivered to the load, and that output will be the power load. It is usually used for last output stage of a circuit. Example, here we having the audio power amplifier, that is in the loudspeaker, there with the power output will be in the form of the audio. Servo motors also, servo motor controllers also the type of the power amplifier. Push pull amplifiers and RF amplifiers are in the category of the power amplifier. So then the classification of the power amplifier is very important on the basis of its characteristics. The another type of the amplifier is the AF amplifier. AF amplifier means the audio frequency amplifier, which are used to amplifying the signals in the range of the human hearing according to the 20 Hz to the 20 kilohertz. And although some hi-fi audio amplifier extend the range up to the around 100 kilohertz. So while other audio amplifiers may restrict the high frequency limit to the 15 kilohertz or the less. So audio frequency amplifier amplifies the audio signal that will be in the range of the human hearing. Audio voltage amplifier used to amplify the low level signal from the microphones, tapes, disc and the disc pickups etc. So with the extra circuitry, they also perform functions such as the tone correction, equalization of the signal levels or the mixing from different inputs. They generally have high voltage gain and medium high voltage gain. It means the voltage output is high, and the medium high output resistance, medium to the high output resistance. So this type of amplifier are used generally in the audio signals. Audio power amplifiers are used to receive the amplified input from the series of the voltage amplifier and then provide the sufficient power to the derived loudspeaker, and that will give the output. The audio power amplifier are used to receive the amplified input from the series of the voltage amplifier and then provide the sufficient power to drive the loudspeaker. So next is the IF amplifier. Audio frequency means where is the audio. IF amplifier, which is the intermediate frequency amplifier, which are tuned amplified used in the radio, TV and radar. To increase the sound, we use the audio frequency here. Just to get the louds, that we use the intermediate frequency amplifier, that tuned amplified used in the radio, TV and the radar. Their purpose is to provide the majority of the voltage amplification of a radio, TV and radar signals before the audio and video performance carried by the signal is separate demodulated from the radio signal. Now they operate at the frequency lower than that of the received radio signal but higher than the audio or the video signal eventually produced by the system. So that's why it is in the intermediate frequency amplifier that operates at the frequency lower than that of the received radio signal but higher than that of the audio signal. The frequency at which the IF amplifier operates and the bandwidth of the amplifier depends on the type of the equipment used. For example, we use the radio signal. So AM radio receive the IF amplifiers operates around the 470 kilohertz and their bandwidths normally 10 kilohertz, that will be the 465 to the 475 kilohertz, while the TV commonly use the 6 megahertz bandwidth for the IF signal at around the 30 to 40 megahertz, and the radar bandwidth of the 10 megahertz may be used in such type of the signal. This is the diagram how it works. This is the antenna, RF, amplifier, then IF, FM, AF audio frequency. As in this we get the signal as well as we are having the audio and video. So both the signals are used, both the frequencies, both the amplifier are used in this FM radio diagram, right. Next is a RF amplifier, that is a radio frequency amplifier, which are tuned amplifier in which the frequency of the operation is governed by the tuned circuit. This circuit or may not be the adjustment depending upon the purpose of the amplifier. As we know that we change the radio signals, we changing its amplification, like that we changing is a tuning, and after changing the tuning we can amplify its signal, and it is governed by the tuned circuit. So bandwidth also depends upon the use and may be relatively wide or the narrow. Input resistance is generally low or is gain. Now the RF amplifiers have little or no gain at all, but are primarily a buffer between the receiving antenna and the later circuitry to prevent the high level of unwanted signal from the receiver circuit reaching the antenna, while where it could be retransmitted as a interference. So this RF amplifiers has no gain. A special feature of RF amplifier where they use the earliest stage of the receiver of the low noise performance. In the radio frequency, there is a very low noise because of the FET transistor are used in these stages. So important in the background noise generally produced by the electronic device is kept minimum because of amplifier will handling very low amplitude signal from the antenna. That will be the microvolt or smaller than that of. That's why most commonly used FET having a low noise signal. Next type of amplifier is the ultrasonic amplifier. Ultrasonic amplifier are a type of audio amplifier that handle the frequency around 20 kilohertz up to the 100 kilohertz, and that are usually designed to specific purpose such as ultrasonic cleaning, metal fatigue detection, ultrasound scanning, remote control system, etc. Each type of operates over a fairly narrow band of the frequency within the ultrasonic range. Next type of amplifier is the wide band amplifier. What is this type of amplifier? This wide band amplifiers must have a common gain from DC to several tens of the megahertz. Wide band means it is a wide band as name suggests that its band is very high. It works in a larger band system. So wide band amplifier must have a constant gain from DC to the several tens of megahertz. So it is used to measuring the equipment such as oscilloscope, where there is a need of accuracy measurement and over a wide range of the frequency because they are extremely wide bandwidth, and in this type of amplifier the gain is low because of the wide range. So wide range amplifier having a low gain. Next type of amplifier is a DC amplifier. DC amplifier are used to amplify the DC 0 Hz voltage or a very low frequency signal where the DC level of the signal is important, and they are common in many electrical control systems measuring instruments. Next is the video amplifier. Name suggests that the video will be amplified. So video amplifier, a special type of the band amplifier that also preserve the DC level of the signals that are used to specifically the signals that will apply to the CRT, cathode ray tube, and other display units. The video signal carries all the pictures of information in the TV, videos and radar system that will be displayed, that will be amplified. So the bandwidth of the video amplifier depends upon the use of the pixels we are using, and the TV receivers is extend up to the DC to the 6 megahertz or in the wider range still in the radar. Thank you very much.